This video is about AVL trees. These are a type of binary search tree. They're balanced search trees. This balancing ensures that the depth of the tree is about O log n, and searches through this tree will be O log n at worst. The balance comes through ideas of the height of nodes in a tree and the balance factor of a node that is not a leaf. We use dummy leaves to calculate the balance of a node. Alright, let's look at a tree. So here we've got the tree in blue. Every node that's not a leaf needs to have two children, so we've inserted a dummy leaf here and a dummy leaf here. These have a height, by definition, equal to -1. So if we go through this here, this leaf has a height of 0, its node has a height of 1, its parent has a height of 2, and going up we've got a height of 3. This is the longest path from the root to a leaf in this tree. So the height of this tree is equal to 3. Here we've got a height of 0, height of -1 by definition again. Here height 1. Right, so now what we need to do is calculate the balance factor for the nodes that are not leaves. Balance factor here equals 1. 0 minus -1 equals 1. Height 1, height 0. Balance factor equals 1 minus 0 equals 1. Height 0, height -1. Balance factor equals 0 minus -1 equals 1. Up here the balance factor will be height 2 minus height 1, which equals 1. So when we look at the balance factors, all of them have a magnitude that is less than or equal to 1. Magnitudes of -1, 0 and 1 are okay. Anything bigger than that in size is a problem. The tree is not balanced. Alright, let's look at a tree that's not balanced. So here we've got a tree in blue, and we've got 3 dummy nodes, dummy leaves. Each of them has a height equal to -1. And what we need to do is, starting from the bottom of the tree, go through, work out all the heights, and then also work out the balance factors. Well, we've already got some of the height information there. So here, let's work out the balance factor here. -1 minus 0 equals -1. Here's a height of -1, and here's a height of 1. -1 minus 1 equals -2. We've got a problem here. This balance factor has a magnitude that is greater than 1. Over here is everything's okay. We didn't change anything from the previous slide. Alright, what we've got to do is balance this subtree by using a left rotation. So we know that A is smaller than B, which is smaller than C. So if we rotate to the left, we get A smaller than B, and B is smaller than C. So we replace what's in the green rectangle with this. Let's have a look at it. Here we go. Now over here, height of 0, balance factor equals 0 minus 0 equals 0. Height of 2 minus 1 equals 1. Balance factor is 1. We see the balance 1, 0, minus 1, 0, 1. All of them are less than or equal to 1. So what we now have is an AVL balanced tree. That's it. Thank you.